engineers that I've worked with that work with Rust love Rust in a way that I haven't necessarily seen other languages be loved. And I relate to that because initially I started picking up Rust on the side just to make sure that I understand what's going on. And I went from disliking it to liking it in very fast because it's hard not to love it. It's a beautiful structure. It's kind of taking care of you and allowing you to focus on the important things. So if you are someone looking to go into Rust or someone looking to hire for Rust, you can expect a very strong and supportive community with a lot of information out there to set you up for success.
Hi Emma, welcome to Coding Chats. My understanding is you spent the last couple of years managing teams that use List, so I'd love to talk to you about List. Particularly, what led your team to choose List? What alternatives did you consider?
Thank you for having me, John, to the podcast. I'm very excited to be here. So I think I will mention that the team I'm referring to is the team that I managed at Amazon Prime Video. I'm still managing Rust teams, but it's a new role and I don't have any insights yet about it. So all of my insights today will be coming from my previous job. We worked on the platform that runs the Prime Video application on living room devices. So that's smart TVs, game consoles, and set-top boxes. And as you can imagine, it's very critical for the platform to run fast so that the client application runs fast. So we care about input latency, frames per second. We care that the application doesn't crash at boot time. So the reason we chose Rust is primarily performance. Rust is fast. For us, it was about 20 times faster than our previous architecture. And that was a primary driver. It is also, it was able to maintain our requirements for over-the-air updatability for the code. It's a lot of teams that contribute this code, and we cannot suffer having to ship it natively on devices, have to hand over binary to partners, and we have thousands of different device types we're talking about. It would be an absolute distribution nightmare. So we want to keep that code as small, as slim as possible. So we were able to compile Rust to WebAssembly in order to maintain this updatability over the air. And Rust is a safe language. Rust has strong type system. It has a lot of memory safety guarantees at compile time, which is really appealing, again, specifically because we are a platform team and we care very deeply about not having memory leaks in the application. And therefore, I think Rust was a fantastic choice.
Awesome. That's a hell of an improvement, a 20x improvement. So what were you coming from before?
Right. So previously, the architecture was a JavaScript for the over-the-air updatable layer, and then C++, native C++ beneath it. JavaScript was great because it was over-the-air updatable, but it's hell slow. And we did choose it because React is a very mature framework, and there's plenty of talent around, and developers in general are familiar with it. The ecosystem is mature, so it does have its benefits. But in our case, we hit a point where we are CPU bound on the more low-level devices. And we needed to just get a bit more juice out of them.
So there's a couple of things I want to pull out there. I have only met software engineers that are familiar with over-the-air updates who have worked in mobile telecommunications before. So I think a lot of software engineers, particularly those building websites, are probably not familiar with this concept. Could you explain a little bit of what you mean by over-the-air updates and what kind of constraints that puts on the team?
Certainly. So the Prime Video code that's over-the-air updatable is somewhere in S3, and it's getting downloaded at application start time. So what the native C++ code really does is it downloads that code when the customer hits start Prime Video application with the remote button. And then that's, it spins up some virtual machines, and one of them has become Rust compiled to, it was a Rust virtual machine. Actually, what we did is we migrated in parts. So there was another virtual machine that was JavaScript. And then the code gets downloaded, and then other teams own running the code inside that is actually rendering the application. So we're when I say platform, we're quite low level in the stack. We're talking about drawing pixels on the screen. We're talking about handling the user input. I press play. I want that to happen fast. I don't want to wait half a minute and wonder if the application froze. Does it answer your question?
Yes, it does. So you're talking about the software that's running on the device, so somebody's smart TV, and your over-the-air update is the ability for that system to update. So when we turn our smart TV on, we're going to see there's a new version of this software, and that's being delivered. And as you say, it's going over the air, so we want it as small as possible to minimize the bandwidth.
Yes, that's a really good observation. Yeah.
Cool. And I think that's something that a lot of software engineers are probably not that familiar with. If, again, you look at all over social media and every tutorial, everything's about JavaScript, the web, React, things like that. And we forget, I think, a lot that people are working on embedded systems, people are working on software that runs on a chip, software that runs on a device, and that somehow somebody's got to update all these devices and keep them up to date and provide the things that are running on there. So again, a lot of us are used to building things. I say a lot of us, not me particularly. I don't do front end, but a lot of people are used to front end web stuff and probably not familiar with the kind of constraints you've got. Their target is somebody that's running a MacBook or a Windows PC. What are the kind of typical constraints that you had in targeting the device? What would be the memory, the CPU limits?
I find it very hard to have one answer that fits all, because we're talking about over 100 million devices in total, over 100 million customers that at the scale of Prime Video, and it's over 1,000 device types. It highly depends how you really count them, but you can imagine every major TV provider gets a new model out every year, and every model is going to be slightly different, and there's some that are wildly different. So you have on one end of the spectrum, you have PS5. I love PS5. Strong game consoles in general, they're great. It's butter smooth. It's a pleasure to run the application on them. We don't care about those. What we care about is the lowest end devices. We're talking about set-top boxes. We're talking about some low-end Rokus or Chromecast, where running application is a real challenge. There's no GPU on them. There's just there's one core, and frankly, I don't think they were intended to have something as powerful as Prime Video run on them initially. So that's where the challenge is. That's where it's interesting as well, because you have these constraints. There's very little storage, perhaps. There's very little memory to work with. So that's where something like Rust can be a very powerful tool.
Yeah, absolutely. I imagine that a WASM interpreter is going to be significantly smaller memory footprint and significantly lower CPU overhead than a JavaScript interpreter in VM. So JavaScript to Rust is quite a big transition, and not a transition that a lot of software engineers make. Most people I know that use Rust have come from C or C++. What was it like for the team to make that change from JavaScript to Rust? I mean, they're very different languages.
That's certainly the case. And I can point specifically to last year, because last year we have basically rebuilt a private application to be purely in Rust. So my team built this SDK, this Rust SDK, and then we worked, we interfaced with the Rust client team. And again, we built both counterparts from scratch. So I can talk about from second-hand perspective about JavaScript engineers onboarding to Rust. And in general, I would say it's a steep learning curve. It is somewhat different from maybe the traditional programming languages, specifically around the lifetime and the ownership model of the language. So it does require, I find, a mental shift that takes some time. I would argue onboarding to Rust is slower, so you have an initial dip in productivity. But then, because Rust is safer, it allows you to focus on the features you develop rather than language edge cases. It also makes code reviews go faster. And it kind of levels out the playfield a little between different experience levels. So once you are onboarded, I would, from my experience, I have observed that we bring up really good delivery speed.
So you got maybe a dip for the first 6 months while somebody's getting used to Rust, and then a more consistent higher performance after that, or is it a shorter or longer period in that?
I would I would say about 3 months. We have seen 3 months until a JavaScript developer could hit the expected productivity levels, which is it's not a short amount of time, but if you compare it with onboarding to other languages, I think it's not a huge amount of time. I would point out that we built this SDK last year with React in mind. So we built it such that React developers could onboard swiftly to it. We had like macros, we had signaling effects abstractions. So I think that if you design your system with your customers or developers in mind, I think that helps a lot.
I think 3 months is pretty good, really. I mean, I have seen people take much longer to get up to speed with C++, transition to C++, and join a code base and be productive in that. So I say 3 months is not bad, and probably a good trade-off for all the benefits that you're going to get with Rust as well there. So aside from designing with the developers in mind, was there anything else that you found useful that helped upskill the team so they could transition to using Rust?
For us, it was a mixture of hands-on experience and sort of pair programming or code reviews with more experienced engineers. So that helps a lot. We sort of, let's say we ran some workshops, but more like discussions. And I think the biggest challenge is, again, getting the ownership, the borrowing, and the error handling, all of these Rust-specific mechanisms, getting onboarded with them. So I do think you want to get your hands dirty into the code base and you want to start small and iterate. But it helps a lot having more senior engineers kind of nitpick at your code and kind of rustify your code. And that was, I think, one of the crucial things to get people up to speed fast. And over time, I think I would add that the engineers, maybe the initial challenge is obviously, it may be demoralizing, but you get to really appreciate you have less runtime bugs. You can focus on your code functionality, and your performance is more predictable. Your code performance is more predictable. And yeah, I think overall engineers absolutely ended up loving Rust.
Yes, it does seem to be incredibly popular. Every single Stack Overflow, I think, for the last 7 or 8 years has rated Rust as the most loved, or very close to being the most loved programming language. So if I get that right, then your way of onboarding somebody new to Rust was to give them a quick introduction and then throw them into the code base and start getting them learn by doing with the support of a more experienced engineer. Awesome. I love to hear that. My main thing is coding challenges, all about learn by doing. So it's always great to hear that other people find that's a productive way. Were there any particularly challenges that people found that you maybe modify that approach for? Was there anything, like you've mentioned, the borrow checker and lifetimes? Did you focus any specific lessons or any particular training material on that? Or was it just really get that pair programming with a more experienced person that can show them the way?
Funny you should mention that. Maybe one thing I haven't mentioned, it's kind of ubiquitous, but there's the Rust book. So there's one book, you learn Rust by example. It's extremely comprehensive. It's really clear and crisp and well done. And that's my number one recommended material if you want to start with Rust. If you pair that with support from your team, I think that's going to guarantee a really nice PD start.
Awesome. So you mentioned that there was another team that you were working with. How do you see Rust kind of spreading out across the organization? Were there any challenges? Were there any real benefits to it?
That's a really good question. I think we worked very closely together, and that was one of the key drivers behind the success and the speed. So I would say we worked together at unprecedented speeds. We basically got the whole new app rewritten in about 9 months. And then the impact speaks for itself. So I'm not going to give specific numbers, but we were able to drive the worst cases in terms of input latency to the point where it's not noticeable by customers. So that's a huge win from our point of view. I would say operating as one team, making sure that whatever processes you do have in place serve you well and serve both you and your counterpart teams, but making sure you're giving your engineers plenty of space. So we had to move fast. So our stand-ups were lightning fast, and we did not have them every day. and we trusted our engineers to do their job well. So when you have to work this fast with this many different people, you have to just operate on trust. So I would say, as a manager, focusing on building the trust with your stakeholders and with your team is more important than project management.
Cool. So you talk about moving fast, and 9 months is quite quick. For that transition to building something an entirely new platform, and as you mentioned, there's millions of devices off potentially, I guess, thousands of different hardware platforms. What was your approach to being able to test that, we've rebuilt this in Rust, we've got something to deploy? How do you test and get some confidence at that scale? And what lessons can other people take if they're looking to transition to Rust?
Mm-hmm. So we can think of the testing pyramid with unit test, integration, end-to-end. We have something we call like an enormous test, which is like supercharged end-to-end. And then there's on-device test, which I would argue for us is the foundation in a way. It's where testing really shines, and where you want to, this is where you catch the sneakiest bugs. So Prime does have a bespoke solution on the premises of the office, where these tests are running 24/7. I don't think it's public, but we did work closely with specific teams to set up our testing infrastructure to have a wide coverage. And we paired it with diving deep into dashboards and making sure we have an extremely thorough overview, so that you can monitor during lunchtime. And I would argue the lunch was very smooth.
So presumably you had some sort of in-office laboratory that was full of different devices, and you can deploy and run live tests.
And there's some very clever solutions to make it all automated.
Yes, I remember working on those in mobile phone systems, and I was impressed at the complexity that went into those, and quite glad I didn't have to worry about all the devices and permutations of them. Were there any real lessons that you learned about deploying Rust that you wish you'd known in advance?
Oh, that's a good question. I think, let me pick one. I think with Rust you have these strong memory checks, and you have these great compile time guarantees, but that cuts both ways. So like everything in life, it's a trade-off. So you do have to have really strict runtime discipline. So it does come with a cost, and you need to be prepared for it. So again, maybe at the beginning it's going to you're going to sit deep in productivity until you get adjusted to this. So yeah, I think I'm a big fan of Rust, but I think it's worth just going with your eyes open and understanding exactly what pros and cons you're having.
So most of the people I talk to and know that are using Rust are building systems that are targeting a physical CPU, so an ARM or an Intel CPU. Not many of them are using it to target WASM. I know there are a lot of people doing that, like I think Canva and Figma talked about. Were there any differences in how you use Rust or how you build the code that came from the fact that that was your target platform?
Yes, I would argue the main one is around how you choose to compile it, and namely what pre-compilation optimizations you may apply. So you can always trade off doing more work before at compile time to get better performance. But a trade-off is that's going to be physically like a larger bundle size of the code. And again, if you download that over the air, that's going to going to take longer to download, which impacts application start time, and B, it's going to take more space, which can cause the application to run out of memory, worst case, or just to be slower. So if you apply anything like ahead of time compilation optimization or other options, you have to be mindful of that, because you need to keep the future in mind. If you need to understand the speed at which your code bundle is growing, projecting, what's your end state. So I think that's probably the number one difference I would see from my side.
Yeah, I think again most of us forget that. We forget how constrained we are, and that we can normally target the kind of average device. Well, I think you've got to probably really think in that case about the lowest platform that you support and the implications of that. So with all the trade-offs and the pros and cons you mentioned, do you think the team would go back and choose Rust again today? or would they maybe consider some other options?
Because the performance and the safety guarantees that Rust brings are worth a lot more than the trade-offs that it brings with those. So again, I think it highly depends on your use case. But if you are in the business of working on very restricted devices, or if you simply care about the memory safety or the performance of your application, I think Rust usually is worth it. Yeah.
So if you'll excuse the pun, it's short-term pain for a lifetime of gain then in your team.
Yes, and I think just referencing to the pains, again, the ecosystem is still maturing, but there are at this point, I would say, enough libraries and enough tools to be meaningfully productive. Maybe I would account for the additional onboarding time.
So on that note, you mentioned that the ecosystem is still maturing. One of my concerns when I first looked at Lust 4 or 5 years ago was that constant change. And again, how did you manage and how did you cope with the fact that it is maturing quite quickly and there is a constant change? Did you find the need to kind of pin versions down and fix to a platform, or were you able to kind of cope with staying fairly close to the bleeding edge?
We wanted to stay as close as possible to the bleeding edge while not directly sitting on top of it. So we were following one version and periodically updating. So that's a really good point, because you want to allocate time for keeping up with the tool chains, because it's still evolving. Also, Prime Video specifically has a strategy to keep in touch and even steer or being involved in the way WebAssembly and WebAssembly micro runtime evolve, which is the runtime Prime Video is using, and that's through the Bytecode Alliance. So Amazon is a member of it, and there's a bunch of other companies. I think Intel and ARM are there, as you might expect, and together, there's a committee that's kind of deciding what proposals are moving forward. It's a very complex process, so it's not that simple. But again, it's worth being involved in the open source community. It's worth keeping in touch with the direction it's moving and the latest things that are coming up. If you want to make sure that they keep aligning and you're not diverging interest-wise.
Oh yeah, and thinking about other organizations that might be considering adopting Lust, are there any strong advice you would give them that they should think about?
Again, I think to summarize, you have this strong community momentum around the runtimes and the tool chains. There's a lot of standardization going on right now. It's worth being involved in it. It's worth keeping up with what's going on. And I would say debugging is still more difficult than on more mature stacks like Java or JavaScript. So that's worth keeping in mind. It is still evolving. It's not quite yet mature. You also have less libraries and less frameworks to work with. You also have multiple runtimes, and each of them comes with a slightly different capability. So again, we chose WebAssembly micro runtime. I know we looked at WASM time as well, and there's a few others as well. So you have to kind of make an educated decision on which one is going to serve you best. And they're all being developed. And then it's really worth considering the WebAssembly system interface standards are still evolving as well. So for example, things like shrinking memory. If you grow linear memory, you may not be able to shrinking afterwards, or you may not have multi-thread support yet. So these are quite major things that are not quite yet there that you need to make sure you can work with.
I remember why I like targeting CPUs that have been around a while, not trying to hit a moving target.
Yeah.
So turning that around a little bit then, what about if you're an engineer on a team, your team's looking at building something new and you think that Lust would be good? Do you have any advice to an engineer on how they can sell it to their immediate manager and then maybe to the wider stakeholders?
I think in general, one of the best tools engineers have to convince managers are POCs. So show the impact, build something very scrappy that does almost nothing, but show the potential impact. And that's how, in our case, that's how we started switching to Rust. It was an engineer building a POC and showing it was about 20 times faster than.
Yeah, that's pretty compelling.
Yeah, exactly. It's more than 100 documents.
Yeah, that's more than an ifs and a maybe and I've written this out. This would be great. Trust me. It's like this is great. See, yeah, absolutely. We've talked about the constant changing and trying to stay near the bleeding edge and the maturing ecosystem. That has the potential to create a lot of cruft, or some people might call it technical debt. Combine the fact that you're targeting a lot of devices that are moving and presumably like churning in and out of the ecosystem. Are there any kind of lessons that people could learn of a long time strategy of managing a Rust code base, trying to continue to support systems that might be in the wild versus still be maintainable and keep up with that ecosystem? Basically, managing the lifetime of a large Rust application.
Yeah, that's a really good question. So of course you have tech debt similar to any in any languages, in any architecture. Specifically to Rust, I think you're trading the traditional, the slightly more traditional tech debt where you have race conditions or memory leaks for complexity depth. So it might be a bit harder to change APIs later. It might be harder to refactor code. You have to deal with the ownership and the lifetime. Yeah, I think complexity and I think you touched on it earlier. There's kind of what I call people debt. It's because it's harder to hire for Rust, even though it's very popular. We're still, I think, the industry is still catching up. So if you are changing to Rust, then you're looking for hiring for a quite niche domain. So that's worth keeping in touch. There's a tool chains. So you want to keep in touch with the latest, with the bleeding edge. That's going to take time. So you do want to allocate some extra time for that in your planning.
So you touched on hiring there, Hammer, and I keep seeing people say it's difficult to hire from Rust. And then I keep seeing recruiters and companies post job adverts for Rust that all say 5 years experience of Rust. So it's that typical thing. And we saw this in, I'm old and grey haired. I saw this with Java in the late 90s, where everybody wanted 5 years experience of Java and it hadn't been around for 5 years yet. And I'm sure seen it for every single programming language. I'm sure back in 2012, people wanted 5 years experience of Go and so on. Do you feel that it's a sensible strategy to look for people, if it's difficult to find people with Rust, to look for people with 5 years? Or you talked about transitioning JavaScript people in 3 months. Do you think better to hire people with the right attitude and aptitude that want to learn Rust?
Precisely. I think you're spot on there. So I think hiring for the right mindset, I think hiring. So it's worth understanding the space you're operating in. For my case, for example, it's very low level. It's ultra low level these days. So it takes a very specific mindset to enjoy digging into this really tiny problem and spending like half a year coming up with a solution to a very complex problem, versus shipping features that are beautiful and elegant and high level. So I think that's a lot more important, hiring for the right mindset, than the language, because like you said, you can onboard to it and it's quite scarce right now to hire for Rust. So you're making it easier on yourself. You're kind of dropping some of the requirements.
So in your case, people are like mindset, people that would be interested in that kind of resource constrained environment, the more system stroke embedded level areas. I think that fits a lot of the kind of people that I know that are working on Rust or that are interested in Rust because they've been in, say, back-end data engineering systems, or they've been around like financial trading systems, and maybe not quite resource constrained in the same way, but more resource constrained from the how do we get latency out of this, or low latency out of this massive server. What are the kind of key 1 or 2 attributes that you say will make somebody a good fit for you, or what would you look for in an interview?
I would argue enjoying the complexity of the space that we're operating in, and so showing an interest in digging under the hood to understand deeply how something works. So I'm in a space where depth is the number one keyword versus breadth. All of both the current and the previous team that I'm operating in, these Rust teams, every person is highly specialized into one section. No one can cover everything, and you have to kind of learn to operate in that environment. So again, I think someone showing this depth and this desire to understand deeply how things work, I think it's sort of a stubbornness to not take no for an answer, like to keep pushing the boundaries. We are in a space where sometimes you just have to come up with a solution. You need to make the application fit on the device. You need to just keep looking and keep brainstorming. It's not just on you, but you have to have a certain mindset of having these high standards and continuously pushing.
So very much, if I might use the words I've talked about in the past, that curiosity to dig into it and really want to understand things at a level, and then that resilience or perseverance of, right, I'm going to figure this out and I'm going to stick with it until I do and keep pushing through. Awesome. Yeah, so hopefully people looking for Lust will start changing their hiring things, stop asking for the 5 years of experience and start looking for that curiosity, looking for somebody that's gone out there, maybe started building something in Lust and trying to figure out how to use it and what they can get from it, and has that desire and that excitement. Any other tips that you'd give to somebody that was trying to build a team around Lust?
I think what you touched on now would be my number one tip. I think it's a very smart move to widen your candidates pool, because you're going to get those candidates that the others are not thinking about because they want the 5 years of Rust. You're going to end up with some pretty amazing people that are going to, yes, there's going to be a slight dip in productivity, perhaps for a few months if you're doing it the right way. But again, you always, as a leader, you think about the long-term image.
Okay. And spinning it down from a candidate, what would be a kind of great thing for them to go away and, I appreciate your company may not have this for hiring, but if a candidate was to come to you and say, hey, I've done this in Lust, I've built this, or I learned about this, what would be a kind of a great demonstration that would impress you as a hiring manager?
Mm-hmm. I think first it would be the self-initiative of building something, and then it would be seeing if the candidate understands the impact. So are you just doing something to learn it? That's fine. But what would probably impress me is it's something that's useful, and here's the numbers. It's actually been used by, my friends. It's fine. But having that extra connection, like taking the extra step of how it's actually used on your job is going to make a huge difference. So it's a good thing to look for.
That classic case that we always talk about of showing how it's going to make an impact as well, and understanding that difference and actually solving a real problem that moves the needle on something. Awesome. Thank you very much, Emma. Is there anything else that you'd like to share with people that are considering Lust?
Perhaps just that it's a very exciting space right now. As you mentioned, it's very popular, and in general, the engineers that I've worked with that work with Rust love Rust in a way that I haven't necessarily seen other languages be loved. And I relate to that because initially I started picking up Rust on the side just to make sure that I understand what's going on. And I went from disliking it to liking it in very, very fast because it's hard not to love it. It's a beautiful structure. It's kind of taking care of you and allowing you to focus on the important things. So if you are someone looking to go into Rust or someone looking to hire for Rust, you can expect a very strong and supportive community with a lot of information out there to set you up for success.
Awesome. All right. Well, thank you very much for your time today, Emma. It's been a pleasure. If anyone wants to reach out and contact you, what is the best way? And we'll put the links and stuff in the show notes.
Yeah, you can just reach out to me on LinkedIn. I would love to hear from you. If you have listened to this podcast, I'm happy to answer any questions or just let me know your thoughts. So yeah, I'm looking forward to hearing from you.
Awesome. Thank you very much, Emma.
Thank you.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.